Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video, I'm assuming you already know kind of how to do classes in Ruby. So if you haven't watched my OOP Masterclass in Ruby video, I recommend watching that first, so that way you know how classes inheritance technically work. The purpose of this video is going to more think about when do you use it, like when do I use inheritance, when do I use things like singletons and factories, how to think about it, because you're not just making classes for the purpose of making classes. Theoretically, you could operate and create everything that a class you do with a class just through series of functions. You could do that. The point of creating classes and objects and types is to make the code easier to think through, because it works like things work in real life. Okay? So, for example, okay? Now, let's say this, okay? So let's use an example where inheritance makes sense, okay? And generally, whenever you think of inheritance, it means you're creating like a subclass. So it's something that sort of is a version of the parent class. So let's pretend we have a person class, right? Okay? Now what happens is that a person will initialize it, so def initialize, because in Ruby we have that as a constructor. Okay, we're going to say a person has a name, an age. That's good for now. Okay, name and age. And we're going to make it where you pass in the name. Okay, and so name equals name, and age starts at 0. And then every year, a person ages. Okay, so we'll create a function that says, birthday. And on every birthday, at age equals plus equals 1. Okay, so every year, a person gets a year older. Okay. Now, at the moment, a person can also speak. Okay, and when a person speaks, they will say words. So we will put say words. Okay. So a person does these things. Okay. But, a baby is kind of a type of person, okay? Is a kind of, well, let me think about this for a second. Should a baby inherit from person? Because does a a baby does have a birthday every year. Baby does speak, but here's the thing. We're going to add a function here. Def have child. Okay, which right now is going to be empty. Okay, because we haven't created a way to make a baby yet. Now, the thing is that if I were to inherit a baby from a person, then a baby would have this function. And a baby would not... A baby shouldn't... baby doesn't have children. So in that case, maybe it doesn't make sense to inherit baby from person. Okay? So in that case, maybe what we'll do is we create a separate object, because it just doesn't perfectly pan over. Okay? I mean, you could also just... Oh, actually, here's what we'll do. We're going to create the baby class that does inherit from person, because we'll say baby is kind of like a subtype of person. This is where inheritance gets tricky, because you have to really kind of think through like how things relate to each other. So yeah, a baby is a type of person. So we'll do class baby inherits from person. Okay? And that's why you always kind of want to think through what the thing is before you start coding it. Because what you're trying to do is you're trying to model the thing in code. It's like painting a picture. You have to look at what you're painting before you paint it and think it through. So a baby has all the things on top. Okay, def initialize. And we will call the super constructor. I don't think I need to do anything particularly special here. And Now a baby is gonna still have a birthday every year, so I don't need to change that. Okay, actually I do. Def birthday. What did I call the function? Birthday with a lowercase. Yep, def birthday. Okay. Def birthday, and let's see here. We're gonna say that if if first we have to add the age, so add age equals plus equals 1, so we age each year. But because you're a child, if at age is greater than or equal than 18, then what's going to happen is you're going to return as a person. So you're no longer going to be a baby, but we're going to return a person with your... Actually, so then we have to modify person, so we should actually pass in age. And then we should default to 0. Okay. Let's do it that way. So in that case, we're going to pass in a person, but we're going to pass in at name, at age. Okay, so basically, you become a person. So a person's going to get returned. Okay, on your 18th birthday. Okay, and... Okay, and then speak, def speak. When a baby speaks, it's a little bit different. So instead it's going to say puts wah. Okay, and that's it. And so there we have a baby and a person. Okay. Cool. Now let's see here. How do I want to do this? We're going to create a new baby. And actually we need to make certain properties public. So what I'm going to do is down here, we're going to say atter accessor and then we're going to pass in name and age. Okay. So that way name and age are readable and writable. And then this have child, what it's going to do, it's going to take in a name, and we're going to return a baby.new with the name being passed in as the baby. So there we go. Okay, so let's tell a story. So there's Bob. Bob is a person. Okay. He has the name of Bob, and right now he's 30 years old. Okay. Bob ends up having Stewie. So Bob dot have child Stewie. Okay. So let's put Stewie.age so we can see that he's 0. So let's put that so far. So let's just run this code. So let's make sure I'm in the right folder. Yep. Ruby test.rb. Oh. We got some syntax errors to fix because I started using curly brackets because I forget that I'm in Ruby. There we go. Did I use them anywhere else? Yes, I did. Person. Me and these curly brackets. Okay, and then let's try that again. Okay, at without identifiers is a lot an instance variable. Where do we use that? If at, oh, forgot to write if at age. There we go. End of input, expecting end. So I forgot an end somewhere. Looks like I forgot an end for person. I mean for baby. Do I have an N for person? I don't think I do. There we go. Still missing an N, so let's match these up. Def end, def end, def end. That looks good. Def end, if end, def end, class end. So where am I missing an end? It says line 20. Oh, forgot the word class person over here. Okay, there we go. Class person. There we go. Undefined method person for main object. Oh, person.new. Oh, JavaScript habits. Okay. And wrong number of arguments, expect 0. And that was for line 23. Oh, yep, because I didn't specify a name. Here's an argument. There we go. Cool. Let's try this again. We're almost there. And there we go. Okay, so see, Stewie exists, and he's age 0. Okay, so now let's have Stewie age. Okay, so Stewie... I should just do a loop. So for... I'll just do it the hard way. So Stewie dot have birthday. Okay, and then we'll put Stewie dot age. And then I'm going to put Stewie. So you can see that on his 18th birthday, they're going to have a different result. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We'll stop there. And on that 18th one, we should see a return of a new person because he's hit a certain age. Okay, and then undefined method person. Oh, did I put person dot new? Did the same thing here, right? Return person. Person dot new. Because this is Ruby. And we got to write the word new. And you see on his 18th birthday, we returned a new person. Okay? Because technically that's right before we print his age. Cool. So it works. So he ages, and then on his 18th birthday, a new person of the name Stewie gets created because he's become an adult. Okay, so what we've done is we've just modeled sort of the behavior of real life in code. Okay, so adult persons can have babies, and then babies can age, and then they become a person. And if I really wanted to, I could override the have child, have child here, so that way it can be like, can't do that. So if the baby tried to do it, it'd be like, can't do it. Okay, so you can do stuff like that. But the idea is that I used inheriting a person because there's sort of that kind of linear relationship that sort of, if you could draw a chart, like imagine there's animal, and then, so then like cat would inherit from animal because cat's a type of animal, but then a Cheshire cat would inherit from cat because it's a type of cat. So the idea is that the thing that inherits is always a type of the thing above it. Okay? Now, if we're talking about like a car, let's say, let's just delete all this. Okay, now if we're talking about, let's say, let's first create like a machine. So let's do class car. Okay, and the car prop doesn't really need to even have anything inside of it. Okay, and then we have something called a factory that makes cars. Now, the factory makes cars, but a car is not a type of factory, and a factory is not a type of car. So there's no need for one to inherit from the other. They can still interact with each other. Okay, so I can still sit there and say, okay, def initialize. And we'll say every factory has a name. Okay, and, generally, yeah, every factory has a name, and then every factory has a, cars made array. So an array of all the cars it's made. And yeah, and then it's gonna have a function, def make car. And what it does, it makes a new car. So return, or what it does, it just takes at cars made dot push and pushes in a new car. So this is also what's referred to as the factory design pattern. Okay, car and factory are two completely different objects, but the factory class is responsible for making the cars. Okay, so they don't have to be inherited to do stuff with each other. Inheritance is just if they need to share like functions, that we don't have to rewrite certain functions. But they're completely separate objects. But this function, this class here, can take advantage of the other class's existence and makes cars. So every time, so now if I were to create a new factory, so we'll say Mazda equals factory dot new. Okay, and I should probably make a name property. Okay, we'll call it Mazda, and then we'll say Mazda dot make car. Even though I wrote make care, let's change that. And if I do this like 3 times, okay, and then I need to make the cars made property, adder, accessor, cars made. Okay, so we'll do is we'll put cars Mazda dot cars made, and we can see all the cars that Mazda has made so far. So I'll run the code. Okay, let's see, syntax error number 1. Ask car. I think it just doesn't like that I use the curly brackets. Let's see here. Our syntax error expecting. Okay. Oh yeah, why am I using curly brackets? Or I keep doing that. I should have just done this in JavaScript. Okay, so car. Now it needs an end block. That's why I keep using JavaScript. Okay, see, JavaScript habits die hard. Okay, there you go. And you can see the array of cars that was made. So we made 3 cars, and now Mazda has 3 cars that it's made. Okay, so again, objects can interact with each other. They don't need to be inherited. This is a factory pattern, okay, because what it does is that this class ends up being a creator of the other class. So when an object acts as the way you create things of the other class, that is referred to as a factory pattern. Then there's the Singleton pattern. Okay, so these are 2 where basically you're creating sort of one of a thing. Okay, so let's say the class is me, Alex Merced. How many Alex Merceds are there? Theoretically 1. So even though I'm making a class, we're never going to create many instances of Alex Merced. So there's no need to have instance properties and instance methods. I still may want to have a class because I want this object that has these functions and ability to do things, but I just want there to be 1. In JavaScript, this is easy because you can just make one-off objects on the fly. That's something really unique to JavaScript. Okay, I mean, you can make hashes in Ruby, but really only by creating a class can you get the full sort of breadth of an object. Okay, because technically in JavaScript, classes are really just an abstraction over some of the advanced features of objects in JavaScript, because JavaScript's weird like that. But let's see here. So in that case, my name and age are going to be class instances, so they get 2 @ symbols. So name is Alex Merced. Okay, my age equals 35, and then I'll create some functions to get those. So def age returns at age, and this has to be a class function, so I have to make it like this: Alex Merced.age because you're calling it on the class, not on the instance. There are no instances of Alex Merced. There's no need for multiple Alex Merceds. Although, that might not be such a bad world, right? Okay, so def Alex Merced dot name at name, and okay, and again, I always like to, if you notice, I include my mistakes in my videos. One, because I want you to see that everyone makes mistakes, okay? And all developers make mistakes and work their way through these things. But two, I want you to see how I work through my problems, because that's just as much a part of becoming a better developer as just seeing it done right, okay? Seeing someone kind of make a mistake, fix it, and go through how they fix it is going to be just as valuable. Okay, so Alex Merced at age equals 35, at name, good. So, and the cool thing about this is, see, this is a Singleton class because I'm only intending there to be one Alex Merced. So everything about the way I designed it, I just use Alex Merced. So if I want to get Alex Merced's age, okay, I can just do this, P Alex Merced dot name. There's no need for me to ever do Alex Merced dot new. So then I can print out the name. So I have access to those properties. I can create more functions. That's a singleton. It's like, let's say we create like a math object. Like in JavaScript, there's a math object that has all these math functions. There's only one. You don't have to create a new instance of math every time you use math. It's a singleton. Every time you create a one-off object in JavaScript, that's a singleton. You're creating a one unique object because you only need one. Okay? In most other languages, you can't create one-off objects without creating a class first. So you generally create a class with these kind of, in Ruby they're called class methods and class properties. In most other languages they're referred to as static methods and static properties. But it just means it goes to the class. You don't have to instantiate an instance of the class to use the function to access the properties. They're of the class. Okay, yeah, so I think that's what I wanted to learn. So again, just to recap what we've learned. What we've learned is that when you think about how you inherit things, okay, and actually I will teach you one more thing. But when you inherit things, think about like the relationship between the two things. Okay, like is the thing that's inheriting a subtype of the other thing? Okay, so like a customer is not a type of bank, so a customer doesn't need to inherit from bank. A cup of coffee is not a type of person, so coffee doesn't need to inherit from person, but a person might still interact with the coffee object because that person might drink coffee. Okay? So again, just think of it like real world. Like in a real world, how do these objects, these things that you see, interact with each other? Think of it like painting a picture. Okay? Again, you have the factory pattern where one class creates instances of another class. You have the singleton pattern where you're creating a class is really only meant there to be one of, because you only need one to do the things of. Like if you ever use the express library in JavaScript, you really only create one application object. It's a singleton. You don't create more than one, and there's never really a need to create more than one. It's designed to be sort of a single one thing. Okay? Even though they don't use static methods and properties to do it, you use a function to create the new app object, but the point is it's meant to be one. Now the last thing I want to show you is so inheritance is one way to not have to rewrite code when it comes to classes. In Ruby, they make another approach called composition much easier using what's called a module. So remember the issue I had earlier where basically, to inherit from a person would mean that the baby was going to end up having a have child function. I don't want the baby to have a have child function, but I wanted them to have the birthday function. I wanted them to have a name and an age without me having to redo the name and age property. Like I don't want to have to redo some of that stuff. So what I could have done is created a module. Okay, with the stuff that is going to be the same. Okay, so things that a person and a baby, so we'll say here, module speak. Okay. Let's see here. Module speak. or module people. Let's call that module people. Okay, and we're gonna say people can speak. So def speak. Okay, and speaking puts say stuff. And deaf people can age. Speak birthday. Not 100% sure if this would work, but let's give it a shot. Add age equals plus equals 1. Okay. And okay, so there's the module people. So now when I create a person, instead of creating a baby inheriting from a person, I can just create a person and have them include the module people, so that way it has all the functions that people have. And I'll do that after the initialize. Def initialize name age. So at name equals name, at age equals age. And then they can have the, and then I can do the same thing with a baby. So then this, oh, I'm doing all the curly brackets again. And oh, JavaScript, what have you done to me? Okay, def initialize baby. Let's put the N now before I forget. Now in here, I'm going to want to initialize the baby too. So def initialize name age. Okay, at name equals name, at age equals age. Okay, but I don't have to type in those methods again. I can just do include people. So I include the people module as well inside of baby. So baby's going to have those two functions as well, but only in the person. Here I'll define the have baby function. Okay, and we'll just for the sake of time, say puts had a baby. Cool. So now both, let's just try to test this out first. So again, we have Bob, the person.new, Bob, who's 30. So let's first just test out that that works. Unexpected end of input. So I have an extra end somewhere. Baby def end. Line 22. Oh, is there an extra end here? So def person, def end, person end. That makes sense. Module end, def end. It's probably easier if I do it this way. Just make sure I put all these tabs here. Okay, def speak. Let's run that code again. Include people. Syntax error, unexpected end, expecting end of, oh, forgot the word class here. Class baby and the class person. Why am I forgetting the class keyword? Weird. Okay. Cool. Okay, so that works. It's not, I'm not getting any syntax errors now. Okay, so Bob is a person. Okay, and that's fine. So let's use the function bob.speak. And then I'm going to create Stewie, the baby. Stewie equals baby.new, and that's going to be named Stewie, and say 0, and then Stewie dot speak. So they're both going to be able to speak, say stuff, because they both included this module. So in this case, what I can do is I can create modules that have clumps of functions that might be shared among multiple classes without having them to inherit from each other. This is referred to as composition, where you're thinking of things that things will share even though they're not subtypes of each other. Okay? So for example, a car and a plane are not, a car isn't the type of plane and a plane isn't a type of car, but they can both travel. Okay, so there might be functions that are associated with traveling that I might want in both, but I don't want to inherit from the other. So I'll use composition using modules. Okay, most languages don't necessarily, some languages don't have a mechanism for composition. So like JavaScript doesn't have an explicit mechanism for composition. Some languages only give you composition as an option. So languages like Rust and Go don't even let you do inheritance. Like, it's just not an option. You have to use composition as the way you sort of construct your objects because they don't have classes. So there's different ways different languages kind of push you towards. But the idea is that you have all these different sort of approaches and types that you can use. Okay, so hopefully you guys found this interesting. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.